Hi everyone, welcome to a new video. In this video, we focus on the probabilities of determinant. So if you are interested in how to calculate the value of the determinant, then refer to another video on the channel. But here we're mainly focusing on studying the probabilities of determinant. And these are useful sometimes. It allows you to calculate the determinant in a faster way if you notice certain characteristic of the determinant. So let's get started. So the first property is this. If any row or column is 0, then the determinant is 0. So, for example, if you're looking at this determinant, we can see that we have a row of 0. So, immediately the value of this determinant is 0 without doing any calculation. Similarly, in the second determinant here, we can see that there is a column that consists of 0. So, also the value of this 0. You don't need to do any calculation immediately. The value of the determinant is 0 in these cases. The second property is that if we have two rows or columns that are the same, then also the determinant is 0. For example, if we look at the first determinant here, we can see that the first row and the third row are the same. So this means the value of the determinant is 0. So you don't need to do any calculation directly. You can write that the determinant is 0. If we look at also at the second determinant here, we can see that the first column and the last column are the same. So immediately we can write the value of the determinant equal to 0. Next, if one row or one column is a multiple of another row or column, then the determinant is also 0. If we look at the first determinant, we notice that the third row is a multiple of the first one. It's twice actually, the first one. You can see 2 times 2, 4, 2 times 1, 2, 5 times 2, 10. So the third row is a multiple of the first one, so the value of the determinant is 0 here. In the second determinant, if we compare the first column and the third column, we also see that the first column is twice the third column. So 1 times 2 give you 2, 1.5 times 2 give you 3, 2 times 2 give you 4. So this also 0. Next property, if two rows or columns are interchanged, then the sign of the determinant will change. So for example, if we take the first determinant, we can easily calculate this. 3 times 2, that gives us 6, minus 1 times 4 gives us 4. So this gives us 2. Now, if you notice, the second determinant is actually the same as the first one, except that we interchange the first row with the second row. And so the determinant, without actually doing any calculation, will be minus 2. So the sign only will change. So we know that the original one have a determinant of 2. Here we interchange two rows, so the sign will be minus 2. And of course you can easily verify that. 1 times 4 is 4, minus 3 times 2, that is 6. So 4 minus 6 give us minus 2. But actually, using the properties, you don't need to do any calculation. You can directly find the value. Next, the determinant of an upper or a lower triangular square matrix is the product of the diagonal element. For example, so first let's look at the first determinant. Here we notice that this is the main diagonal, and all the elements below the main diagonal are 0. So this is known as upper triangular square matrix. So according to this property, if we are trying to calculate the determinant, what we have to do is to multiply the element in the diagonal. So it will be just 5 times 6 times 3. 5 times 6, that is 30, times 3 give us 90. The second example, we can see this is again the main diagonal, and all the elements above this main diagonal are 0. So this is known as a lower triangular square matrix. And again, we can calculate the determinant for this case by multiplying the elements in the diagonal. So it will be 1 times 2 times 3 give us 6. Okay, next, if a row or a column is multiplied by a constant, then the determinant is also multiplied by the same constant. So let's look at this example. So let's say that we already know what's the value of the determinant as we see here. We know that the determinant here minus 16, and this particular example is solved in the other video that show how to calculate the determinants. So you can check it there if you are interested to see the detail. So we already know that this determinant is minus 16. Now we have another determinant and we're trying to calculate its value. So what we notice here is that these exactly are the same. Nothing is different except in the third row. what we notice that in the third row, the value here are twice the value here. So as if we take the first determinant and we multiply the third row with 2. According to this property, what we need also to do to get the value of this new determinant is to multiply the determinant with the same constant. So it will be simply 2 times minus 16. This is the original value for the determinant, and this is the constant that the third row is multiplying with. So this gives us minus 32. Again, without doing any calculation, we're able to find the determinant based on the probabilities. We already know the value of the original determinant. Next, if a constant multiple of a row or a column is added to another row or column, then the determinant will not change. Let's illustrate this with an example. So again, assuming that we already know the value for this determinant, now let's say we do the following operation. We take the third row and we add it to the first row, and so this becomes the first row. Okay, so if you notice, the third row is 5, 0, 3, and we add it to 1, 2, 3. 5 plus 1 give us 6, so that will become the new value for the first element in row 1. Then 0 plus 2 give us 2. This become now the second value for the first row. 3 plus 3, that give us 6. Now this become the new value for the third element in row 1. According to this property, because what we did is just added row 3 to row 1, the value of the determinant will not change. So the value here actually will be minus 16. Now let's do another operation which is illustrated in the third determinant. So here we're doing 2 times the third column plus the first one, and this will replace the first column. So what we're actually doing is that we're taking twice the third column and we are adding it to the first column, and that will be the new value for column 1. So looking at column 3, first element is 3. If you multiply it with 2, that gives you 6. And if you add it to the value for the first column, which is 1, 6 plus 1 gives us 7. The second element in the third column is 2. You multiply it with 2, it becomes 4. And you add it to the second element in column 1, which is also 4, that gives us 8. So this becomes the new second element in column 1. The third element in column 3 is 3. You multiply it with 2, give us 6. You add it to element 3 in column 1, which is 5. So 6 plus 5, that gives us 11. And that becomes the new value for the third element in column 1. Again, according to this property, because we just added a multiple of a column to column 1, that should not change the value for the determinant. So this also is minus 16. Next property, the determinant of the transpose of a matrix is the same as the determinant of the matrix itself. In other words, transposing a matrix does not change the value for the determinant. So here again, we are starting with the same determinant that we used in the previous examples. So we already know that this is the value for the determinant. What this property is saying is that if you take the transpose, the determinant remains the same. What do we mean by the transpose? It means simply that you take every row and make it a column. Okay, so first row now become the first column. So we'll have 1, 2, 3. Second row become the second column. So it become 4, 1, 2. The third row become the third column. 5, 0, 3. Okay, so this new determinant, which we get by making the rows columns, and actually at the same time the columns are becoming rows, is minus 16. So the value does not change by taking the transpose of a matrix. Okay, next, if A has an inverse, then the determinant of the inverse is simply the reciprocal of the determinant of the original matrix. So for example, if you take this matrix, we know that the determinant of A in this case is 2 times 4 give us 8, minus 1 times 3 give us 3. So this give us 5. So if we need to find the determinant of the inverse, according to this property, it will be 1 over the value of the determinant for the original matrix, which is 5. So this will be 1 over 5. So you can see we can get the determinant of the inverse without actually having to calculate the inverse itself. There is no need to calculate the inverse and then getting the determinant. You can directly get it using this property. So that's it for this video. If you find this video useful, please give it a like and consider subscribing to the channel and turn the notification on so that you get notified about new content. Thank you for watching.